Good morning, everyone, and welcome to 1.2 Rotation Symmetry and Transformations. Let's begin. There are two definitions to be aware of. Number one is center of rotation, which is the point about which the rotation of an object turns. Essentially, that's the middle of the shape. Okay? Rotation symmetry occurs when an object can be turned about its center of rotation so that it fits onto its outline more than once in a complete turn. Well, it is somewhat of a complicated explanation. Essentially what it means is, as you turn the shape, so if we were to rotate this square in one complete 360-degree rotation, how many times would it look exactly as it does right now? For a square with 4 equal sides, it would have an order of rotation of 4. So in order for something to have rotation symmetry, it has to look like itself more than once. Okay? The order of rotation is the number of times that a shape or design fits onto itself in one complete turn. For a hexagon here, with 6 equal sides, the order of rotation would be 6, because in one complete rotation, there's 6 times it would look exactly as it does right now. And for this pinwheel type shape, with 4 equal pieces jutting out, the order of rotation would be 4. 4 times will it look exactly as it does right now. Next up, once you've determined the order of rotation, you can find the angle of rotation. The angle of rotation is the minimum measure of the angle needed to turn a shape or design onto itself. To calculate it, you take 360 degrees divided by the order of rotation. So for our square, which had an order of rotation of 4, to find the angle of rotation, we would go 360 degrees divided by the order of rotation, which is 4, so the angle of rotation would be 90 degrees. Here's a couple more shapes to try that out with. So we've got a flag here, a pentagon, and another 4-sided shape here. We'll start with the flag. The order of rotation would be 2. As the rectangle, it will look like itself when it's upside down, and then when it gets back to the beginning. So the order of rotation is 2. To find the angle of rotation, we're going to go 360 divided by 2. So the angle of rotation is 180 degrees. To find the angle of rotation as a fraction of a turn, well, we start with one complete turn, and the order of rotation is 2, so that means every half a turn you will see the same picture you do right now. You don't use the angle of rotation as a fraction very often, more the times it's spent with the degree. For the pentagon, with 5 equal sides, the order of rotation is 5. The angle of rotation, 360 divided by 5, is, calculator to turn on, 72. And then the angle of rotation as a fraction, start with the one complete turn, divided by the order, is 1/5. Every 1/5 of the turn, you will see the same shape. Finally, for this one, the angle or the order of rotation in this shape is actually just 1. The only time it will look like itself is when it gets back to the beginning. So this shape doesn't actually have rotation symmetry. If the order of rotation is only 1, it doesn't have rotation symmetry. So the angle would be 360 because it takes a full turn, and the fraction would be 1. It takes one complete turn to make this shape look the same. Alright, here are 3 more shapes for you, so if you could pause the video at this point and fill out the table for the order of rotation, angle of rotation, and the angle of rotation as a fraction, that'd be great. So please pause now. Now that you've had a chance to try, let's look at the answer. For the flag here, the Métis flag, the order of rotation is 2. The angle of rotation, 360 divided by 2, will be 180. And as a fraction of a turn, it's 1 over 2. For this next shape here, the only time it's going to look like itself is when it gets back to the beginning. The order of rotation is 1. The angle of rotation is 360. And the fraction is just 1. Here we've got a triangle. 3 equal sides, and the inside has 3 equal pieces, so the order of rotation is 3. The angle of rotation, 360 divided by 3, is 120, and the fraction of a turn is 1 over 3. Next question. Sometimes shapes have both rotation symmetry or line symmetry, and sometimes they have both. So in this case, they've given us 3 shapes. They want us to identify what type of symmetry does it have, be it line symmetry from 1.1 or rotation symmetry. If it has line symmetry, we have to say how many lines of symmetry it has, and whether they are vertical, horizontal, or oblique. And then for each example of rotation symmetry, we have to give the order of rotation and the angle of rotation in degrees. Got the answers on the next slide here. This first shape has rotation symmetry. There's no lines of symmetry here where we could cut this and fold it onto itself. So this is rotation symmetry. The order of rotation would be 3, and the angle would be 360 divided by 3 would be 120. With these 5 circles, there's no way to have rotation symmetry for that. The order of rotation would be 1. But it does have a vertical line of symmetry. We could cut it right down the middle here, which would give us rotation symmetry, and, it would give us line symmetry. It's a vertical line of symmetry. The angle of rotation would just be 360. This final shape has both rotation symmetry and line symmetry. The rotation symmetry is 2, so 360 divided by 2 is 180, and it has 2 lines of symmetry, 1 vertical and 1 horizontal. Here's a chance for you to give that a try, so if you could pause the video at this point and fill out the type of symmetry that this shape has, the number and direction of the lines of symmetry, and the angle and order of rotation. Please pause now. Now that you've had a chance to try, let's look at the types of symmetry. First, we can see that it does have line symmetry. It has a vertical line of symmetry there, and a horizontal line of symmetry here. So 2 lines, vertical and horizontal. Now the order of rotation is 2. It'll look like itself when it's upside down, and then once more when it gets back to the beginning. So the order of rotation would be 2. The angle of rotation would be 360 divided by 2, which would be 180 degrees. That brings us to the end of today's assignment. Your questions are on page 21, 4 to 7, 9, 13, 14, 17, and 20. You will have a quiz on 1.1 and 1.2 to do today as well. So I'd like you to finish this quiz first, or finish the assignment, and then attempt the quiz on Microsoft Teams. And don't forget to like and subscribe so that you are informed of all future videos. Thank you. Have a good day.